sometimes problems don't have a solution. I'm sorry to tell you that. There are times in life when we have problems and there's not a solution to it. We're going to see some of those for homework tonight. All right. Now, there are three things that we're going to look at for when word problems don't have a solution. Maybe not enough information is given. That's one. The facts lead to an unrealistic result. You get an answer, right? You do the math and you get an answer, but the answer doesn't make sense in terms of the problem. For instance, the side of this triangle is -2 feet. Okay, you can't have a side of a triangle that's -2. Doesn't make any sense. All right? Or when you do the math, the facts are contradictory. You get something like 4 = 12. Okay? Now, we're going to look at 3 problems today, an example of each one of these. All right, so let's look at the first one here. The first one says, I'm sorry, yes sir?
On our homework, are we just going to put like a solution?
Some will have answers, some will
Well,
not.
you're gonna on your homework say why. Not enough information, it's unrealistic, or it's contradictory. Those are the 3 possibilities, but you have to show why. Exactly. So example number 1, look at this one. It says, for the first 2 hours of her trip, Jenny Chang drove her normal speed, but then road repairs forced her to drive 10 miles per hour slower. This sounds familiar. Than her normal speed. Still, she made the trip in 3 hours. Find her normal speed. Well, this is like section 4.8, right? This is what? First part of the trip, second part of the trip. Just to distinguish them, you know you've got 2 parts, right? Rate, time, and distance. Rate, time, and distance. What was the rate on the first part of the trip? Do we know that, Dylan?
It's like regular speeds. Or
You would just say
normal
R?
speeds, so just say R.
Because they didn't say how fast it was. So what was the rate on the second part of the trip?
R minus.
R minus 10 miles per hour slower. Okay, fine. Grace, what was the time of the first part of her trip?
2 hours.
2 hours. What was the amount of time for the second part of her trip? Well, it doesn't say it outright, but you can figure it out. Because it says that she made the trip in 3 hours. So it's 1 hour. Okay? So when I multiply, right, because distance equals rate times time,
Yeah.
so I'm going to get 2R and then 1 times R minus 10. Now, at this point, what we've done in the past, we've said, okay, either these 2 distances are equal to each other, or we add these 2 distances to get the whole distance of the trip. Well, let me ask you something. Do we know that the first part of her trip is the same distance as the second part of her trip? We don't know that. Do we know that the 2 distances will give us the total amount of her trip? Well, we know that, but do they give us the total distance of her trip? Was it a 1,000-mile trip? Was it a 20-mile trip? We don't know. This doesn't give us any numbers about distance whatsoever. So our answer is not enough information. We need the length of her trip, or we need to know that they're equal to each other before we can write an equation. All right, those are the 2 possibilities with distance. All right? Okay, good job. Let's look at the next one.